Welcome to Lucid Mind Chemistry channel. In this video, I have compiled questions related to the properties of group 2 carbonates, nitrates, sulphates such as stability, solubility, decomposition, reactions, etc. For similar topics and question timestamps, read video description. Question 35. Strontium nitrate is heated strongly for several minutes. Which statements are correct? Let's write the chemical equation for the decomposition of strontium nitrate. We have SrNO32 converts into strontium oxide, nitrogen dioxide, and oxygen gas. Part 1 says a brown gas is produced. Now NO2 is the brown gas. So this option is correct. 2. A gas is produced that relights a glowing splint. Yes, we have oxygen gas which is produced, so part 2 is also correct. 3 says a white powder remains after heating. So strontium oxide is actually white in color. So therefore all 3 options are correct. So the answer is A. Question number 16. A white solid Z is soluble in water. A sample of Z is heated with a Bunsen burner until there is no further change. When the residue is shaken with water, a solution is formed with no solid remaining. What could Z be? It says Z is soluble in water, so let's first find out which of the substances A, B, C and D are soluble and insoluble. First one is magnesium carbonate. Magnesium carbonate is insoluble in water. Magnesium nitrate is soluble. As all nitrates are soluble, barium carbonate is insoluble. Barium nitrate is soluble. So therefore the Z could be magnesium nitrate or barium nitrate. Now let's find out what happens when this is heated until there is no further chemical change. So magnesium nitrate when heated on the Bunsen burner produces magnesium oxide along with nitrogen dioxide and oxygen gas. We can balance this chemical equation using this molar ratio. Among the products, magnesium oxide is in solid form, nitrogen dioxide is a gas, oxygen is also a gas. So in the question it says when the residue is shaken with water, a solution is formed with no solid remaining. So among these products, magnesium oxide is solid and it is insoluble in water. So therefore it is not magnesium nitrate. Second option is barium nitrate. Let's first write the chemical equation for barium nitrate. When barium nitrate solid is heated, it forms barium oxide, nitrogen dioxide and oxygen gas. Again we have to find whether barium oxide is soluble in water or not. So barium oxide does dissolve in water. So barium oxide is soluble. Hence barium oxide will form a solution with no solid remaining. So therefore answer is barium nitrate, D. Question 14. A 5 gram sample of an anhydrous group 2 metal nitrate loses 3.29 grams in mass when heated strongly. Which metal is present? Let's start by writing a general equation of metal nitrate from group 2. It decomposes into metal oxide, which is solid, along with nitrogen dioxide, which is gas, and oxygen, which is also gas. Let's balance this equation. We have metal M on both sides, which is equal. Now the number of nitrogen atom is 2 on the reactant side, so we can write 2 with the product. There are 6 oxygen atoms on the reactant side, so therefore we can write 1 by 2 with the oxygen to make it 1. So the total oxygen atoms on the product will be 6. In the question they have given 5 grams sample mass, so therefore the mass of metal nitrate is 5.00 grams. And it says that after heating strongly it loses 3.29 grams, which means that the mass of these gases was collectively 3.29 grams, which is lost. So therefore the mass of metal oxide that is left will be 5 minus 3.29, which is equal to 1.71 grams. As we can see that the number of moles of both metal nitrate and metal oxide is equal in the balanced equation. Both have 1 mole each. Therefore we can write number of moles is equal. Now using the formula of moles is equal to mass in grams divided by molecular mass. Let's find the molecular mass. We have nitrate, nitrogen is 14, 1 oxygen is 16, so 3 will be 48. As there are 2 nitrates, so it will be multiplied by 2, so it becomes 124. The atomic mass of M is still unknown, so we can write M plus 124. Similarly on this side the number of moles is equal to mass in grams divided by molecular mass. We just have 1 oxygen atom, so the molecular mass is M plus 16. The mass in grams is given, which is 5 gram for this compound and 1.71 grams for this one. So we can write 5 divided by M plus 124 is equal to 1.71 divided by M plus 16. By cross multiplying we can find the molecular mass of M. So now it will become 5 into M plus 16 equals 1.71 into M plus 124. Now it will become 5M plus 16 into 5, which is 80, and 1.71 M into 1.71 into 124, which becomes 212.04. Now 5M minus 1.71 M equals 212.04 minus 80. So it becomes 3.29 M equals 132.04. Dividing both sides with 3.29, this will cancel out, so M equals to 40.133. From periodic table we know that the atomic masses of magnesium is 24.3, for calcium it is 40.1, for strontium it is 87.6, while for barium it is 137.3. So our value is equal to the one with calcium. The answer is therefore B. Question 15. Solutions P and Q each contain a different group 2 ion at the same concentration. One contains magnesium plus 2 and the other contains barium plus 2. Tests are carried out on separate 5 cm³ samples of P and Q. In test 1, they have added 1 cm³ of 0.1 mole per decimeter cube sodium sulphate, while in test 2 they have added the same amount of sodium hydroxide. What are the results of these tests? As we have magnesium plus 2 ion present, so it will make magnesium sulphate in the first test, while in the second test magnesium plus 2 upon addition will form magnesium hydroxide. Similarly, barium plus 2 will form barium sulphate in the first test, and in the second test it will form barium hydroxide. As in the results, we have to find out the precipitation, so therefore let's find out which is more soluble among sulfates and among hydroxides. Now we know that group 2 sulfates become less soluble moving down in the group, so therefore magnesium sulfate is more soluble and barium sulfate is less soluble. So therefore more precipitate will be formed with barium plus 2 in test 1. So option A and B could be correct. Now comparing the solubility of hydroxides, we know that in group 2 the hydroxides become more soluble moving down in the group, so therefore magnesium hydroxide is less soluble and barium hydroxide is more soluble, so therefore more precipitate will be formed with magnesium plus 2. The answer is therefore B. Question 13, which statement about the compounds of group 2 elements magnesium to barium is correct? A. Carbonates of group 2 elements produce bubbles when added to dilute nitric acid. We know that all group 2 carbonates produce salt, water and carbon dioxide in the presence of dilute acid. As carbon dioxide is in gaseous state, so therefore bubbles will be produced. For example, if we have calcium carbonate, it will react with dilute nitric acid. It will form calcium nitrate along with water and carbon dioxide. So option A is correct. In B, it says nitrates of group 2 elements produce nitrogen and oxygen on heating. As we know that all group 2 nitrates in the presence of heat they decompose and form metal oxide along with nitrogen dioxide and oxygen gas. For example, if we have calcium nitrate, upon heating it will produce calcium oxide, NO2 and oxygen gas. In the question they have given nitrogen, so therefore nitrogen is incorrect. So option B is wrong. Option C, oxides of group 2 elements produce bubbles when added to dilute hydrochloric acid. We can say that group 2 oxides are actually metal oxides, so therefore they are basic in nature and they will react with HCl to form salt and water. So as no gas is being produced, so therefore no bubbles will be seen. For example, if we have calcium oxide, it will react with dilute HCl to form calcium chloride along with H2O. Calcium chloride is aqueous and water is in liquid state. So option C is also incorrect. In D, it says the oxides of group 2 elements are amphoteric in nature. As we know that group 2 elements are metals and the oxides of metals are basic in nature. So therefore this is also incorrect. So the correct option is A. Question 14. When equal volumes of saturated solutions of barium hydroxide and calcium hydroxide are mixed, a white precipitate Y forms. The mixture is filtered and carbon dioxide is bubbled through the filtrate, producing a second white precipitate Z. What are Y and Z? As we know that in group 2 hydroxides, what happens that as we move down in the group, the solubility increases. So therefore we can say that calcium hydroxide is less soluble than barium hydroxide. So when barium hydroxide and calcium hydroxide are mixed with each other, what happens that the solubility of barium oxide will be high and calcium hydroxide will become a precipitate. So precipitate Y is calcium hydroxide. And the filtrate will be barium hydroxide. So as carbon dioxide is bubbled through the filtrate, we can write the chemical equation. CO2 will react with barium hydroxide and it will form barium carbonate along with H2O. Barium carbonate is insoluble, so therefore it is in the form of precipitate. So precipitate Z will be BaCO3. So Y is calcium hydroxide and Z is barium carbonate. So the answer is C. Question 15. A solution contains both magnesium plus 2 and strontium plus 2 at the same concentration. The solution is divided into two equal proportions. Aqueous sodium hydroxide is added dropwise to one portion. Dilute sulfuric acid is added dropwise to the other portion. Which row is correct? Precipitate seen first when sodium hydroxide is added. Precipitate seen first when sulfuric acid is added. Now we know that magnesium forms magnesium hydroxide with sodium hydroxide and strontium will form strontium hydroxide. Similarly, magnesium will form magnesium sulphate with sulfuric acid. Strontium will form strontium sulphate with sulfuric acid. As magnesium and strontium both are in group 2 of the periodic table, so we know that the solubility of hydroxide increases down the group. For sulfates, the solubility decreases down the group. It means magnesium hydroxide precipitate will be seen first and strontium sulphate will be seen first. The answer is therefore B. Question 18. When 3 grams of an anhydrous nitrate of group 2 metal is decomposed, 1.53 grams of gas is produced. What is the nitrate compound? Now the formula of group 2 nitrates is MnO3 2. Let's find out the molecular masses of all these 4. As in nitrate, we have 2 nitrogen atoms, 6 oxygen atoms. So the molecular mass equals 124 for nitrates. For beryllium, the atomic mass is 9. So 9 plus 124 equals 133. For calcium, the atomic mass is 40.1. So 41.1 plus 124 equals 164.1. For magnesium, the atomic mass is 24.3. So it becomes equal to 148.3. For strontium, the atomic mass is 87.6. So it comes equal to 211.6. Now let's write a balanced chemical equation for decomposition of group 2 nitrates. So we have metal nitrate of group 2. It decomposes to form metal oxide, nitrogen dioxide and oxygen gas. We can balance this equation by writing 2, 2, 4 and 1. Or you can also simplify the ratio by writing 1, 1, 2 and 0.5. As we know that only NO2 and O2 is the gas, metal oxide is solid, so we have to consider these 2 moles and this one. Let's find the number of moles of the reactant. The mass is 3 grams. So as number of moles is equal to mass in grams divided by molecular mass. So 3 divided by 133 will be equal to 0.0225. Similarly, for calcium nitrate, the number of moles in 3 grams will be equal to 0.0183. For magnesium nitrate, it is 0.020. For strontium nitrate, it will be 0.0142. Now, starting with the first one, we have beryllium nitrate, whose number of moles is 0.0225. As we know that for 1 mole, 2 moles of NO2 are produced. So for 0.0225, 2 into 0.0225 moles of NO2 will be produced, which is equal to 0.045 moles. Let's find the mass of NO2. The molecular mass is 14 plus 32, which is equal to 46. So mass in grams is equal to moles into MR. As moles is 0.045 and molecular mass of NO2 is 46. So mass in grams come equal to 2.07 grams. As the combined mass of these two gases was given as 1.53, so it is less than our value, so it means it is not beryllium nitrate. Let's do the same for calcium nitrate. We have 0.0183 moles. So for NO2 it will be doubled, which equals 0.0366 moles. Now converting it to mass is moles into MR. Mass in grams come equal to 1.683 grams. Again 1.683 is greater than 1.53, so therefore B is also wrong. Now doing the same for magnesium nitrate, as the number of moles is 0.020, so NO2 will be doubled. Now finding mass. Again this is greater than the given amount, so it is also incorrect. Now doing the same for D, as we have 0.0142 moles, so the number of moles of NO2 will be doubled, 0.0142 into 2, which equals 0.0284 moles of NO2. And for oxygen the number of moles will be half, as it is 1:0.5, so 0.0142 divided by 2, it comes equal to 0.0071 moles. Let's find out the mass. Mass is equal to moles into MR. So it comes equal to 1.306 grams of NO2. Similarly for oxygen, the mass equals moles into molecular mass of oxygen, which is 32. So it comes equal to 0.2272 grams of oxygen. Now combining both of these gases, we have 1.306 plus 0.2272. So it comes equal to 1.533 grams. Now this is exactly equal to the value given in the question, so therefore D could be correct. The answer is therefore D. Question 16. In group 2 of the periodic table, the properties of elements and their compounds show regular change down the group. Which property shows a decrease from magnesium to barium? First is the decomposition temperature of the carbonates. Now the carbonates of group 2 become more strong as we go down the group. This is because the size of cation increases and the size of anion is already larger. So therefore more overlap is present. Also the polarizing power of cation decreases, so therefore the decomposition temperature of carbonate will increase. So A is incorrect. B is the decomposition temperature of the nitrates. It is similar to carbonates because in nitrates also cations and anions is present and the size of anion is quite larger. So from magnesium nitrate to barium nitrate, the decomposition temperature will increase. This is because size of cation increases and polarizing power of cation decreases. So B is also incorrect. C. The solubility of hydroxides. Now we know that magnesium hydroxide is less soluble, and as we move down in the group, barium hydroxide is very much soluble in water. So the pH of barium hydroxide is quite high, it is equal to 13. So the solubility of hydroxide increase, so therefore C is also incorrect. D. The solubility of sulfates. Now in sulfates we can see that magnesium sulfate is more soluble as compared to barium sulfate, which is insoluble and it forms a precipitate. So the solubility of sulfates decrease from magnesium to barium. So D is the correct option. Correct answer is therefore D. Thanks for watching. If this was useful, please do like, subscribe and share.